Good morning, everyone. Myself, I am G. Charan from Triple E branch. Today's my tech talk topic on digital electronics is the current steering digital to analog converter. The current steering digital to analog converter is a widely used circuit architecture for converting digital signals into analog voltages. It is known for its high speed performance, excellent linearity, and low power consumption. The circuit is often referred to as a circuit for all seasons because of its versatility and applicability. The basic principle behind a current steering digital to analog converter is to generate a current proportional to the digital input code and then convert this current into an analog voltage using a resistor network. The digital input code typically consists of a binary representation of the desired analog voltage. In a current steering digital to analog converter, a series of binary weighted current sources are used to generate the required current levels of the digital analog converter current. These current sources are controlled by switches that are controlled by the digital input code. By selectively enabling or disabling the switches, the approximate combination of current sources can be activated to generate the desired current. Enabling or disabling the switches that are controlled by the digital input code, the current from these sources are then summed together to obtain the analog output voltage. One of the main advantages of the current steering digital to analog converter is its high speed operation. Since the current are switched rather than converted into voltages, the settling time is typically faster compared to other digital to analog converter architecture. This makes it suitable for applications that require fast and accurate conversation, such as high-speed data acquisition, audio systems, and telecommunications systems, etc. Another advantage is the excellent linearity provided by the current steering digital to analog converter. The binary weighted current sources ensures a linear relationship between the digital input code and the generated current levels. This results in a more accurate representation of the analog output voltage. Furthermore, the current steering DAC offers low power consumption by utilizing current sources and switches of the circuit can be designed to consume minimal power when compared to other digital to analog converter architecture. The current steering digital to analog converter replaces this resistor element in the resistor digital to analog converter architectures with a MOSFET current elements and uses some form of the summation of the current elements to produce the result. Sometimes the result needs to be a current such as in integrated bias circuits, such as in integrated bias circuits. Current steering refers to the common method of steering of a current source to from resistive loads to develop a voltage signal. We have current steering digital to analog converters that switches current to resistive loads and develop a voltage signal in communications. One such advance is the One such advance is the concept of current steering or the use of multiple simulation sources to direct current flow through targeted region of brain tissues. The circuit current steering replaces the resistor element in the MOSFET. Sometimes the result need to be a current such that among various digital to convert analog converter realization. The current steering topology offers the highest speed and becomes the de facto solution at gigahertz frequencies, especially if the analog output must be delivered to a resistive load. In this article, we study these digital to analog converter design principles among the current steering Digital to analog converter is a circuit architecture used to convert digital signals into corresponding analog voltages. It operates by generating a current that is proportional to the digital input code and then converting this current into an analog voltage of digital to analog converter circuit of the architecture. Design principles among the digital to analog electronic circuit converter. The key concept behind a current steering digital to analog converter is to use a set of binary weighted current sources controlled by switches. These current sources generate currents that are multiples of a reference current by selectively enabling or disabling the switches based on the digital input code. The switches based on the digital input code, the approximate combination of current source is activated to produce the desired current of the switches. To play the key concept behind a steering of digital to analog converter. The generator currents are then summed together using a resistor network to create an analog output voltage. The resistor network converts the current into a voltage based on Ohm's law V is equals to I into R. The digital input code determines the combination of current sources of the Ohm's law is equals to V is equals to I into R. Code determines the combination of current sources, hence controlling the output voltage level. Current steering digital to analog converters offers several advantages. First one, high speed. The switching nature of the circuit enables fast setting times, making it suitable for high speed applications such as data communications or video processing. Second one, linearity. Binary weighting ensures a linear relationship between the digital input code and the generated currents, resulting in excellent linearity in the output voltage of the current. Third one, resolution. Current steering digital to analog converter can achieve high resolution by employing a large number of current sources and switches. Low power consumption. Fourth one, low power consumption. The architecture allows for power efficient operation by using current sources and minimizing voltage depends power dissipation. Fifth one, compatibility. Current steering digital to analog converter can be easily integrated into complementary metal oxide semiconductor. CMOS full form is complementary metal oxide semiconductor process, making them compatible with the standard digital integrated. These features are make the current steering digital to analog converter a versatility choice for various applications, including audio system, data converts, waveform synthesis, telecommunications, and instrumentations. It has been extensively researched and published in the fields of integrated circuit designs. Here are some features that having the choice to various applications is including audio system, data converters, waveform synthesis, telecommunications, and instrumentations, with numerous improvements and optimization proposed by over the year. Thank you.